Here is example number 2. We're going to determine the relative extrema of this rational function. So the first thing we're going to do is determine the derivative using the quotient rule. Make sure you practice that and get the derivative. I'm going to go to Wolfram alpha and get the derivative, and that tells me it's x times x plus 2 over x plus 1 squared. It's not a difficult derivative, so I don't want to spend time on it. You definitely should probably practice it. So that's that. So now I'm ready to start going. First thing I'm going to do is determine the critical numbers. Critical numbers, according to this derivative, are x equals 0 and x equals -2, because that's where the derivative is 0, and possibly x equals -1. Actually, all of them are really kind of possible. You have to make sure that they are all defined in this original function. Now, 0 and -2 are definitely defined in the original function. -1, that's what made the derivative undefined. That's the one you really have to pay really close attention to. It is undefined in the original, so it's not critical, but it's still very important. It's a vertical asymptote. And anything can happen at a vertical asymptote. So it's important to know that, because the function can still go from increasing to decreasing at a vertical asymptote, even though it's not a critical number. So we're going to have to consider it. So I want to show you how I consider this in a chart. When I set up my chart with the critical numbers, I'm going to include the asymptote, because again, anything can happen there, it can change, and I need to know that. So my critical numbers are -2, -1, and 0. With the asymptote, I'm going to use a dashed line to remind me it's an asymptote, because if it goes from increasing to decreasing, say here, I can't call that a relative extrema because it's not a point on the graph. So that's going to remind me of that whole thing. So now we should check the values of derivatives in each of these intervals: -infinity to -2, -2 to -1, -1 to 0, and 0 to infinity. So the first one, I'm going to use f prime of -3 to see if it's increasing or decreasing in this interval. So when you plug -3 into the derivative, remember, we are using this derivative. Use your rules of multiplication if it's factored, and this is all factored. So we'll have a -3 times a -1, which is 3. But you don't have to think of the value. It doesn't matter. You just want to know if it's positive or negative. So I have a negative times a negative, which is positive, all over. Now, anything you plug in the denominator is going to be positive, because the whole denominator is squared, and any number squared is positive. So that's positive, and positive divided by a positive is positive. So the next 3 intervals, I already know that the bottom of the fraction is going to be positive because it's squared. We need to pick a number between -2 and -1. It's unfortunate that these intervals are so close to each other. Are these extrema, or these critical numbers and vertical asymptotes, I mean. But it's not that big of a deal, because we're just going to use the rules of multiplication on this. So I can pick f prime of -1.5, and it's not going to be that hard to determine if this is positive or negative. Because when you plug -1.5 in here, you get a negative times a positive. -1.5 plus 2 is obviously positive. So a negative times a positive, which is negative, over the bottom, which is positive, and then negative divided by positive is negative. So let's go. We're increasing in this interval. We're decreasing in this interval for the asymptote. Here we're going to have to check f prime of negative 0.5. If you plug negative 0.5 into this x, you get a negative, and negative 0.5 plus 2 is positive, so a negative times a positive, which is negative, over a positive. So it's just like the last one, it's decreasing. Finally, here you can pick any number you want in the interval. I'm going to pick, I'm not trying to be a wise guy here, but the point here is this. It can be any number in the interval. This number is in the interval. And it doesn't really matter what the number is because we don't care what the value is. We just care if it's positive or negative. So if you plug this number in here, it's obviously a positive, times obviously a positive, over we already know that's a positive. So we found out the intervals that it's increasing and decreasing. The question was determine the relative extrema. So the relative extrema, remember, can only occur at critical numbers. So the only two candidates here are 0 and negative 2. Negative 1 is important because this could have changed. But if you look at negative 2, it's a relative max at negative 2, comma. Now, if you're taking the AP exam, I want you to look at the justification I'm going to use. The only way to justify a relative max at this point is because the derivative, you had to put it in terms of derivative, goes from positive to negative. Don't say because the graph goes from increasing to decreasing, you won't get points for that. So anyhow, I still need this y coordinate. So if you plug negative 2 into, again, the original function, you will get positive 4 over negative 1. Decreasing here, it doesn't really matter because it's an asymptote. It won't be a relative extrema. At this critical number, it goes from decreasing to increasing. So we have a relative min. Now I want to change what I said here. If we're looking at AP stuff, we're not going to say because it goes from decreasing to increasing. We're going to say because the derivative goes from negative to positive. That's what makes it a min. So that's at 0 because f prime goes from negative to positive. And the y coordinate at that point is obviously, if you plug it in here, it's going to be 0. So that's it. We're done. Those are the relative extrema of this function. We're going to take a look. So graph it on your graphing calculator. I went to Desmos. It's easier for you to see. There's the function. We have a max at negative 2, comma negative 4. That's what we got. And we have a min at 0, comma 0. And it looks like we have this asymptote at x equals negative 1. So everything looks really good. I think next one we're going to do a trig one. So stay tuned for that and have fun working on these problems.